And we're live. Hello, everyone. Welcome to Serverless Conf Bhubaneswar. This is the first edition of Serverless Conf of Bhubaneswar chapter, and here we are back with back-to-back sessions from wonderful speakers who are subject matter expert in the area of serverless. So let's start by looking at the schedule of the conference. So we are going to kickstart the whole conference from the first event, that is blockchain meets AWS serverless. So this is going to be given by Dhaval Nagar, who is the first speaker of the day. Then we will look into ways to do, uh, you know, things with GraphQL using Azure Functions. Then we have some exciting sessions on Azure Container Apps where we are going to predict red wine quality using deep learning. And we'll be using Azure Container Apps and Azure Kubernetes over there. And that will be given by Ambrish Ganguly. And finally, we'll close up the day by the last session of the conference that is going to be running containers on Azure Functions. That's going to be given by Abhishek Mishra. So that's the crux. That's the event schedule that we have, and I'm excited. I hope you are excited too. So now that we know about the event schedule, let's give a shout out to our sponsor. So JetBrain is the official sponsor for the event. They have given us some licenses, which we are going to share with the attendees of this conference by organizing a raffle. So stay tuned for the updates on the quizzes. Next, Microsoft. We'd like to thank Microsoft for supporting this event. So Microsoft is going to share some goodies with the attendees, and yeah, please stay tuned for updates on that as well. So I'll be posting about these updates, these quizzes, or if, other raffles which are going to be active throughout the conference. So have a look at the comment section. You'll be updated about that. Then I would like to thank the community partners, ServerlessDays Bhubaneswar, Utkal Techies Forum, and Azure Developer Community for making this conference happen. And finally, I would like to give a shout out to Utkal Tech Labs for helping us create the posters and organizing the thing. That's all from my side. And about the event side, let me add the first speaker of the conference. Hello, Dhawal. How are you?
I'm fine. How are you?
I'm doing good, and I'm equally excited to look forward to your session. As shared earlier, blockchain serverless. That's completely new. This is the first time I'm maybe hearing this, but looking forward to the session.
Thank you. I mean, like I said, I have been exploring a bunch of things. We'll see how it goes. Let me share the detail that I have, and then I think everyone. And then I would like. Is there a way that people can actually ask the questions, and then I can try to answer those? Is there a format like that, or just a
Yeah, definitely.
session?
So the thing is, people can post their questions on the comment
Mhm.
section, and I can put it on the screen. And after your whole session is done, probably we can have a Q&A for 5 minutes where you can answer all of the queries.
Sure, that will be wonderful. Fine. Thank you.
Wonderful. Uh, Let me add your screen, and we can get started.
Let me know if you can see it, and I'll start.
I can. I can. So the screen is all yours.
Okay, thank you. Without any much time, I'll start away with my presentation. My name is Dhaval Nagar. I run a small company. We are all doing things around the cloud consulting, uh, cloud native development, and stuff like that. We are also AWS APN partner. I've been AWS Hero since 2020. I'm also AWS SME, the certification. I have completed a bunch of certifications from AWS in past and also contributed into the AWS certification exams. So the topic is like Ashirwad mentioned. It's quite interesting. I've been a long time cloud practitioner. I started playing around with the Lambda and other managed services or serverless services from the early days, early 2015 to mid 2015. First Lambda, then the API gateway, SQS, SNS, and those kind of things. So I've been developing serverless based application for quite some time, and they are good. They are as you may have seen from the documentation in other places, they are pretty stable, reliable, cost effective, and easy to get on board. So Blockchain is now kind of, it's a next wave of the technology. It's changing the way many companies are building and delivering solutions. So it's kind of a decentralized ledger. Some of you might be familiar with the concept, and for some of you this might be new. So I'll give some brief about the blockchain first, and then I will introduce that where and how I'm using or combining the serverless piece or serverless services from the AWS with the blockchain-based application. So blockchain is nothing but a decentralized ledger where not one entity or not kind of centralized entity is doing anything, but the software is run on a in a trusted environment among the peers. Anyone can be part of the network. Even I can actually join the network with my laptop. That may not be possible to do anything, but I can still be part of the network, overall network. It's immutable in a way that how the blockchain works. It doesn't once a new record that has been added inside the ledger, that ledger is kind of distributed among the peers. Analogy wise, I think it is similar to how the torrent works. Like everyone knows torrent, how we basically distribute certain files and the medias through the torrent, and it cannot be shut down because that torrent is distributed. That file is stored not on one or a small set of servers. It is stored on many servers simultaneously. So there is no easy way to actually kind of stop it or change it. Similar way, the whatever is content that has been added inside the chain, that is distributed among the peers, and once it is added, confirmed, it is hard to change practically. It's transparent because all of this content is stored on public nodes. These nodes participate and make a chain. So whatever information is part of the chain, that is visible to almost everyone. You cannot change it, but you can still see, and that actually works as one of the core principle of a blockchain, that in a trustless environment you can store something which is a tamper proof and it is transparent. So once the information is saved, you cannot change it, and it remains there as a proof of the information. It is private in a way that how you interact with the chain. Anyone, like the origin of the blockchain goes back to the Bitcoin, and even before that. I mean, Bitcoin is not the first blockchain. There are many other systems that actually designed to do the kind of an encrypted private transactions among the community. So the private part here is that there is no known identity. Like in a normal application, many of the applications that you use, they ask for your email address, your phone number, and any other identification. So that's kind of a proof of entity that you are submitting, and then based on that, all your interactions are kind of recorded. In case of a blockchain, you are interacting with the chain as a in terms of a cryptographic key, which is part of your wallet, whether the wallet is you owned, you manage, or a wallet that is managed by kind of another entity, another custodian. But in a way, the interaction with the chain is private because it only deals with a cryptographic hash as in terms of an entity. And as a person, I can own dozens of wallet addresses with myself. So when it comes to the email, I will usually go for a very small number of email addresses or phone numbers because it's hard to manage, and it can link back to me as an entity. But when it comes to the blockchain, I can actually have as many number of wallets as I want, and I can make sure that my identity remains pretty private. Safe, all of those above principles make it inherently safe. It is nearly impossible to hack. Now that's basically the practical and the cryptographic aspect of it, that once the information is kind of saved, people actually kind of share that information, and once it is shared, the chain is very difficult to change. So once the information is embedded and saved into that, it is shared. Now if anyone wants to change it, they will need to actually modify the chain, and that is the hard part from the current practical standards. I'll not go into the detail of that, but 51% attack is just one example of how you can actually mutate or change this chain. Now, the typical transaction, like I'll also go through these things in a very simple manner, just to kind of keep this presentation on a lighter side. So the typical transaction that gets into the blockchain is it starts from your interaction side. So the usual way to interact with any of the blockchain-based application right now is the web browser. That you actually open up your browser, you go to the application which is uh, considered to be a Web3 application. You want to kind of save something, or you want to actually add some or mutate some kind of an information and save it into your target chain. So you create the packet of data. Okay, you have to sign that packet, because that's where you need to present to the chain that it is coming from kind of uh, a wallet, a very specific identity, even though it is cryptographic, but it is signed by a specific user. Then the transaction goes into the transaction pool. It doesn't go into the chain directly, it goes into the transaction pool. From the transaction pool, the mining nodes. Mining is a very generic term nowadays, because there has been a lot of news lately around the blockchain and the NFTs and minting and those kind of things. So once your transaction is part of the transaction pool, from there the nodes will pick up your transaction. Now the transaction picking depends on a lot of economic and other incentive part. But let's say that your transaction is picked by the nodes. These nodes are basically doing the minting stuff. So these are kind of technologically capable nodes, having the right amount of resources and everything to actually perform mathematical calculations. And if they are successfully able to solve this mathematical calculation, they will present this entire block. So your transaction is part of a block, and they'll present that block, that okay, this is the new block that I have solved. It contains one of the many transactions, and I want to actually tell it, present it to the chain, and let the chain validate that and then confirm the proof of the transaction. So once the chain receives that block, every node validates that block with a similar formula. And then if everything goes fine, that transaction is complete. And whatever is the original piece of information that you actually sent to the chain, now that is embedded inside the chain. Now, it will take usually from the chain to chain, from the consensus protocol, that the internal mechanism on how people actually arrive that this work has been done by a legit miner, and whatever is presented inside this block is a valid kind of a transactions. That is a separate side. But once it is validated that this block is proper, it is part of the chain, and then it is safe to assume that your information is kind of properly saved inside the chain and it cannot be tampered. Different chain, different mechanism, takes a while from the six blocks to some other mechanism, but eventually you will be able to confirm that your transaction, whatever is the original piece of information that you presented, that is now part of the chain itself and it cannot be changed. Now, before I actually jump into the other part, I want to just say one thing out loud, that the core principle of a blockchain based application is to make sure that it actually act and remain as a decentralized. It is not dependent on any centralized component, which actually defeats the core purpose of being decentralized. So if you are saving things on the chain, you have a reason, you have a purpose, that this information I want to save, just so that it remains kind of tamper proof, it remains secure, safe, and at the same time it is open and transparent, so that people can actually look into that and verify that yes, this is the same information which everyone wants to believe. Like an ownership, a simple ownership of a virtual or a physical asset, if you are saving it on the chain, that means you are basically whoever that kind of ownership is entitled to, they are the owner of the asset and not anyone else. So this entire presentation involves some of the components which are off the chain, which are centralized in the nature because we are using cloud. So yes, it actually defeats some of those principles, but then we are only saving the information which has no dependency on the core information that we are saving onto the chain. So the data that we want to make safe and secure, that stores onto the chain, but only the ancillary part, or only the support data is also only saved onto the off-chain components. And will, if the time permits, we'll also see that some of the Web3 components are also now facing the centralization issues because of the current state of the ecosystem. So when we say blockchain application, so the first blockchain who actually made it popular, so you can write decentralized applications in Ethereum as a blockchain. Bitcoin has a very limited scripting. It is mainly used for the transaction, that is a value transferring the Bitcoin from the one account to another account. But Ethereum made it possible that besides saving the data in a decentralized format, you can actually save your custom code onto the chain itself. You can execute your code, and your code will actually mutate the information saved onto the chain itself. So that actually kind of started the Web3 movement, where the applications are stored onto the chain. They cannot be changed. Your code is immutable. Once you upload your code into the chain, it cannot be changed. And that creates, modifies, and generates a new set of data. So Ethereum works as a whole. Ethereum as an entire network works as a Ethereum virtual machine. So virtual machine is basically a playground. It's a sandbox area which executes your code. Your code is known as a smart contracts. Usually, the preferred way to write these smart contracts is a Solidity. That's a preferred language for the Ethereum blockchain. Your data and code both lives on the chain. It's very interesting that your code lives at a particular address on the chain. So you have a hexadecimal address, and that address is basically, you can actually check that what exactly is on that particular address. And when you open that into your Etherscan or any other block explorer, you will be able to find that it actually shows that on this address there is a smart contract, and you can attach the identity verification proof and the code, actual code as well, for people to actually view what the code is doing. Application functions are executed by the chain nodes. So that is, once your code is deployed onto the EVM, if you want to execute any functions, it has to go through the mining process. It cannot be executed without that, because your transactions are doing something. You're changing the state of the blockchain, so it has to go through the standard mining process. The state of the application is replicated across the node. So if your application is saving the some kind of data, let's say you want to save how much you earn in this work this month, and how much you spend in this month, and you want to save it in a way that it cannot be changed at any point of time. So you can build your own smart contract. You can actually whenever you receive your kind of a salary or income, you just save it onto the chain through the smart contract, your own smart contract. And now once it is saved, you cannot change it. You can modify some piece of it, but you cannot alter whatever you have previously saved. So this makes the whole processor tamper proof, and you have, over the period of time, you create a kind of ledger entries that anyone can, including yourself and others, can actually go through and validate. So this is the visualization of the same process, where external entity, these are the users. There are two external kind of interacting entity. One is a user who owns the wallet, who has the access to the wallet, and who has the ownership of some of the currencies, digital currencies. Another is a smart contract inside the chain itself. So I, as an external person, want to add or want to do some kind of a transaction inside the Ethereum. So I will actually present the information. I will use my wallet address. I'll create a transaction either through very standard wallet software like MetaMask or Rainbow. I can write a custom signer as well. But the preferred way to do it is from your browser. Either you use the dedicated browsers or you use the extensions. You actually wrap up your piece of information, and they'll do the sign, and they'll actually add that transaction into the mining pool. From there, the nodes will pick it up. They start executing, and then Once someone resolves the calculation, your transaction, if it is part of that block, that will become part of the blockchain. So the blockchain is nothing but a sequence of blocks. Each block contains the transactions, and each transaction contains the identity, as in terms of the wallet, and what exactly is the kind of information that has been changed or added or modified in that particular block. All the previous blocks remain intact. Only the new blocks will have the new information. All the previous block will have the old information. This is one of the very simple example. I assume that all of you who are actually attending this, they are pretty much familiar with the standard programming concept. So there is a very simple smart contract. The syntax will look familiar with the JavaScript language. So here the contract is basically a counter contract. I am just kind of incrementing a number, decrementing a number, which are two mutating transactions. Incrementing the number changes the state variable, that is a count. So count is part of the contract. It is by default a state variable. So once this particular code is part of the blockchain, the count will have a default value that is 0. And then if I send a transaction that is inc increment, then it will have, the new block will have a new value that is 1, because it is incremented by 1. And then if I actually send 10 transactions in a sequence, eventually it will have the value of 10 as a current value, but all the previous blocks will actually show you that what exactly was the value in the previous blocks, when it was 8, when it was 7, when it was 5, and when actually it was 0. Same way for the decrement. And the get is nothing but just a query functions. I can actually query the data from the chain easily as well. Now, most of you have heard about the NFTs and the tokens. So token is a very standard concept, that how you actually do or carry out some of the work onto the chain. If you need to own something, it is kind of one of the standard is a token. You have some tokens, like you have some ethers, you have some the other chain tokens. And this is a very simple example. I'm using a library, OpenZeppelin, which is an extremely popular library to actually build safe and secure smart contracts. So this library has a kind of a predefined class. I'm creating, using that class, inheriting the functionality of that class, and creating the ERC20, which is the ERC standard for creating tokens, new tokens. It is not same as NFT. NFT is separate standard, ERC standard. This is the tokenized token standard. So here I can actually tell that who is the owner of this token. What if I'm actually customizing it a bit. So I'm actually adding a company name. Who is the company who is owning this token? What is the name of the token? What is the total supply of the token? So if I want to create my custom tokens, share it with my friends and my co-workers, I will create my own token and kind of share it with the people that I want to share it. So typical interactions right now, as of now, is this: the users interact with the wallet software like MetaMask, and they actually send the transactions to the edge nodes. They actually send the transaction into the transaction pool, and from there, the mining nodes will actually pick it up, will solve the puzzle, and your transaction is now part of the chain. So you can interact with web software, web wallet, or you can actually do it from the back end as well if you are using the custom libraries and you want to interact that. So it's very standard. As of now, it's very standard interaction. If you are actually going to a very uh, the, some of the standard known application like OpenSea for the NFT marketplace, or you are going for the Uniswap as a kind of a DeFi application, you will see that this is the very standard way to interact with a decentralized application. So structure wise, it's kind of similar to how our normal web 2 applications look like. We have some in this case, we user wallet works as an identity. So in the web 2 world, our identity is like a Google sign in or a Facebook sign in or a Twitter sign in. But in case of a web 3, the identity is wallet. Which wallet you want to utilize, which address or account you want to utilize to interact with a target application. Your front end, your normal web front end, that through which you will interact with your decentralized application, your actual contract. So this is the contract which is part of the chain and lives at a particular address. So consider this as our backend application, our APIs, that from the front end we call the API and we carry out the work. Your backend applications, consider this as a microservices or a side application which works along with your application, which is doing some kind of an additional work, analytics, notifications, or some kind of other work besides your regular uh, uh, regular APIs. And the off-chain data storage. Every application uses some kind of data storage services. That includes your standard SQL, NoSQL, or any other kind of a databases. It uses the file storage to store the media. If you're building the media specific application, then you need the streaming services. You need the scalable storage solutions, the CDN to actually host your web applications or host your some of the media assets. So this is in line with what exactly we have been kind of familiar with in our Web 2 or the current normal applications. This is one of the example use case that I want to actually highlight throughout this presentation. So I built a small decentralized application where I, as a company, can create my own tokens. Let's say I want to create 1 lakh tokens, that is 100,000 tokens, and I want to keep it on site, and I want to share these tokens with my staff, with my contributors, employees, or in future with my investors as well. But not in a normal way that, okay, here is the 10,000 tokens that I'm giving to you because you have done this work. I want to do it in a way that here is a 10,000 token that I'm allocating to you, and if you work with me for 1 year or 2 year, you will receive 20% of this allocation after every 3 months or 4 months. So this process, why I want to actually put this into the blockchain, because I'm actually transferring the value. These tokens represent my company onto the blockchain. Okay, and I want to allocate these tokens. Which will have some future values, and I want to do it in a way that it is open and transparent, and it is immutable. So I cannot change it. I cannot suddenly make my 20,000 or 100,000 tokens to 1 million tokens, and suddenly it will decrease the overall value. So I want whoever I am allocating and whoever I'm transferring, they should be able to validate that my company has the valid pool of tokens. I am allocating it to the different people, and I'm not double spending, or I'm not manipulating these tokens, which will have some kind of future value. If my company grows in certain areas, if it has a value, this token will have some byproduct value, and I don't want to manipulate that. So that's why this is kind of a typical example of where blockchain can help in actually storing the true values. So front end, as I said, front end is like a web. We can use the web uh, browser, very dedicated browser, or uh, extensions, like in case of a wallet software, MetaMask, it's a standard extension into the Chrome. You just install it and it will present there, and it will inject some kind of additional Web3 tooling as well. But this is all happening for your Web3 front end. So you need to store your uh, HTML, CSS, JavaScript somewhere, right? I mean, that's the first place where people will actually land themselves and start interacting with your application. So these are some of the example applications. If you go through any of these applications, they are having their standard interaction is through the web. Web applications, web single page applications, which is hosted somewhere, and then that application becomes a bridge to your blockchain. So the Uniswap, the Pull Together, and the OpenSea, these are the very popular applications. You can use it through any browser, and then interact with the blockchain and with the digital asset directly. The standard mechanism is your browser extension will work. Your basically your front end application will work with your wallet software, and then it will present the transaction to the blockchain. So this has to be kind of hosted somewhere, right? So I still see a lot of people, even though we are, this is 2022, and there are a lot of alternatives, there are a lot of documentations and the detailing available. Still, I see a lot of team, lot of developers. They actually host their application onto standard servers. I very recently, I mean, I can good people, good team, but they are so much focused on to what they are doing. They consider that the front end is still very much part of your entire software, like your client server software. So they host the front end exactly where they are hosting the API, which is not a right way to actually consume your server CPU and other things. So in case of an AWS, this is the first entry point. I mean, S3 and CloudFront is extremely popular. I don't know why a lot of people are not using it. There are alternatives. It's not that this is the only two services that you can use for the web hosting, but we are talking about AWS and serverless. So this is when I design the Web3 or Web2 based applications, then if it has any kind of a web as an interaction point, my first preference is that we need to make sure that it is part of the S3. So S3 is not just an elastic web storage; it also works as a hosting as well. And then the CloudFront is nothing but a on edge CDN, very performant, very powerful, and there are a lot of popular websites which are hosted and utilizing the S3 and the CloudFront as a gateway. So Web3, in the Web3 world as well, there are many applications which uses the similar things. You need to host your front end somewhere, because front end is your standard gateway to your blockchain world. So the first entry into the serverless is that you host your front end application, that is your HTML, CSS, and JavaScript, into the your serverless web hosting like S3, CloudFront. We'll see that how the API gateway and Lambda functions also play a role into this, but yes, they are also equally part of this front end based hosting. In the interest of time, I'll go slightly faster. Second thing is storing of the data. Now we are storing the true value of our application onto the blockchain, but not everything that our application need can be stored onto the blockchain. Uh, the blockchain is designed in such a way that if you are using it in a right way, there is an incentive for that. But if you are trying to abuse it, there is no economic kind of a value to you. So if you start storing the image files or the videos, which are pretty large in the size, the way the economic model of the blockchain works is that every space you are consuming, because whatever you are saving inside your contract, inside your blockchain, that is shared among these nodes, and we are occupying their resources, their disk storage, and the other things. So for this information to be stored onto their disk, this node disk, we need to pay some cost. And the big difference from the Web 2 to the Web 3 is that in the Web 2 world, the cost ownership of this data is between the application owners. So if you are interacting with the Google will store all the detail. If you're interacting with Pinterest, they will host everything on their servers and cloud. If you are interacting with YouTube and Facebook, whatever you are uploading, that is stored onto their data centers. You are not being charged to upload something, because this content is a byproduct for them where they are actually making the money. But for the Web3, that's not the case. If you are storing something and if you want to store something, you are the cost center for that information. That means if you are uploading some data, you will have to pay for the data that you are basically consuming the storage. So that's why the Web3 concept is slightly different compared to the Web2, where the cost ownership is among the centralized entity, but in the Web3, the cost ownership, the data ownership, because ultimately it's your data, you are uploading it, so you bear the cost, because the entire chain network is going to store it and protect that data. So whatever data that you are uploading, you will have to pay for it. Given the current state of the blockchain and the economics around that, saving this information will be very costly. I'll not go into the cost distribution of that. I'll show some example in the further slides. But storing large amount of data will be extremely costly for your users. You will say that I'm not paying as a developer of the Web3 application. I'm not paying it. My user will pay it. But then sometimes the user will feel that this whatever is the price that I'm paying, there is no value addition for me to actually store this data. So I will not be able to use this application because the cost is much higher compared to the value that I'm getting in return. So that's why the next piece, where most of the Web3 applications, they offload this data into some kind of an other storage. They do not store it into they do not store the heavy information. They store only meaningful information like the transactions, the ownerships, the addresses, and the allocation. Like for example, the allocation of the token that I have given to someone. So I'll only store that this wallet is supposed to receive 10,000 tokens over the period of time. I'll not store the profile picture. I'll not store the position of that user or the full name or the address of that user anywhere, because that's a meaningful information from the valuable information standpoint. I can store it somewhere else, and I just keep the very true meaningful part which I want to protect and make it transparent onto the chain. And other things can be stored on the chain. So this is just an example that if I these are on the top screenshot. These are some of the transactions, and on the very right hand side, the green value is the cost of the transaction. So if you are executing a method, the average cost in the USD is that much, and it can go pretty large as well, depending on what exactly you are doing inside the method. So each method requires some gas, and then you whatever is the gas that has been kind of consumed, similar to how we drive the car. So the mileage that our car gives, depending, and whatever is the cost of the fuel. Based on that, we can actually find that what exactly is the true cost of moving or transporting from one place to another place. So this is the exact mechanism how the blockchain works, and that's why sometimes the bad actors, they do not try to manipulate or abuse the system, because the cost is much higher to present the wrong or invalid information inside the chain. So for the storage part, again, I'll go to the same thing, that we use the off-chain solutions. I'll again go with the AWS specific services, because this presentation is related to the AWS and not other. But there are many solutions. We can keep the images, the other media files, the JSON data, other detailed information which has no relevance to be part of the blockchain in this other storage mechanism like the S3, or store it into the structured data stores like DynamoDB or other places. And we can interact with those through the standard APIs. So this is another serverless kind of area which is primarily used to store the less meaningful or less relevant information of the chain. The meaningful informations are part of the chain, but less meaningful information, which adds no value to be part of the chain, because there is an additional cost to do that. So we find an alternative which is less costly, and we go with the serverless approach because it is very cheap. There is no additional operations required. It is elastic. We pay for whatever we consume. So that way it can be scaled economically, right? So that's serverless storage is another area. Again, just to give a very quick example, I have seen teams that use the volume storage to store the long-term information, and then when I ask them that you have stored some of these files, but what exactly is the plan, that how long you are going to store it, you have any metrics that how frequently you are utilizing these files or this data. And in many of the cases, they don't have a right idea, because they don't have put any kind of a tooling or any kind of mechanism to understand that what kind of file they want to keep for how long. So that's why it is good to offload it to dedicated storage services like S3, where you can actually maintain the life cycle of the data. The third and the last piece is the post processing, because in case of a Web 2, we have the standard servers, whether it's containerized service, microservice, or a serverless function running somewhere, or your full application running on a virtual machine. you have all the right resources to actually do your actual work, that is saving the data, manipulating the data, doing some calculations, saving into the database and stuff like that. But also the after processing. If you want to save the same data onto 5 different places in a different format, you can do that from your same piece of code. Either you do it in the same kind of a synchronized function, or you use the event driven mechanism like uh, the Lambda and other things to actually share or do the different task after that event has happened. But in case of a Web3, that works slightly different. Your main logic is part of the blockchain. Now, blockchain, the way it is working, you cannot, your smart contract, your Solidity smart contract is a language. There is no way for that language to interact with anything outside. So you cannot have a URL, you cannot call a URL, you cannot call an external API and do something after you execute that transaction. Whatever that has executed, that remains and contained inside the blockchain itself. The only thing it can do is it can emit an event. So again, the event-driven systems is becoming very standard. Lambda serverless is the pioneer in similar area that everything you can construct your entire application with an event-driven approach. Web3 uses a similar thing. You transfer the value, you manipulate something, you add something. The only thing you can do is you can emit an event. That event can be listened through your Web3 interaction application like your HTML, JavaScript, and you can re-render the UI, you can do something else, or you can utilize those event as in terms of your block logs. So that means that event logged a particular entry inside the blockchain, inside that block, and then it can be queried later on to do some kind of additional work. So a simple example for the additional work is that I transferred the token, and I wanted to transfer a token at the end of the next month. And once the end of the next month is hit, I want to actually notify that wallet users. So right now there is no way to actually send out email because wallet is cryptographic address. There is no email attached to that. But let's say I design the application where people can actually register. They give a proof that this wallet is owned by me and this is my email address. Whenever there is an activity happens in terms of a token transfer on this wallet, send me an email. So I can use this kind of a formation, use the event log that has been kind of logged inside the blockchain. I can write off-chain a scheduler which actually continuously checks for the new event. And whenever there is a new transfer event, I see that if there is an email address attached to that wallet in my database, if it is there, I send out an email to that user that you have registered yourself as a email to this wallet, and we see that now this many amount of tokens are transferred into your account. So that actually does the post processing, because there is no way to send email from the chain, there is no way to interact with any third party services from the chain. There are very standard limited way you can do certain things. So event becomes a very standard way to bridge from your on chain to your off chain. So through event you can actually carry out the post processing, the after processing, the additional experience that you would like to have inside your Web3 decentralized application. So this is a very simple example of an event. This is a transfer event. It's one of the most emitted event right now into the Ethereum or EVM compatible chains. This transfer event is a standard ERC20 event, which means that certain number of tokens are transferred from one account to another account. We see that tokens are being transferred every second. So this is the most emitted event into the Ethereum and EVM compatible blockchains right now. It is a very standard. If you are from the any programming language, you will be able to understand that it's a very standard formatted from to and what exactly is a value transfer. The other snapshot is from I wrote a custom DApp, so I can actually have custom events raised, and I can utilize these custom events into my off-chain somewhere in the cloud source cloud application, which actually tracks for this event and does something additional that I want to carry out. Now the third and the important part in this piece is that you are executing certain logic on the chain, but you still want to do a lot of the other logic off the chain. So where and how you should do it. So depending on the way how the Web3 or some of the Web2 applications work, they are very sporadic. So that means the nature of the application is very random. You will have certain number of users at certain point in time, and then you will have no users at all. And in case of a Web3, your off-chain code is mostly working in response to certain things, in response to certain events happening onto the chain. So the typical use case I am actually solving is that I have a listener, I have a scanner, block scanner, which actually works, scans for a new event periodically, like let's say every minute. It scans for the new events that my decentralized application running on an Ethereum blockchain that has emitted, and I want to carry out some work. I want to save it into my database, expose that to the API, do some kind of an additional work, sending out the emails, bunch of other things. So all those things, it's basically a post processing. I call it the Web3 post processing. That is, after certain event, certain transaction executed, it emitted an event, and based on that event, I want to execute certain things, which is it's a first principle for the Lambda or serverless compute as well. That certain event happened, and in response to that event, you are executing certain work. So this Lambda becomes the center of that execution, because that's the very flexible, very scalable, very reliable, similar to the blockchain, very reliable way to execute your code. And it's not just executing it; you can actually do a whole lot of things with Lambda. So I'll not go much in depth with the Lambda, but serverless compute fits extremely well inside your blockchain events, because events are emitted. We can consume those events. We cannot directly consume, but we can actually scan for those events. If you have a JavaScript running in the web browser, you can listen to those and then attach it with your API gateway or something. But if you are doing something purely from the backend point of view, then you need to scan those blocks. And then once you receive the new set of events, you can actually do whatever that you want to carry out. So this is serverless compute fits really well in this, and that's based on my experience, that what I have developed into the Web3 and the some of the web decentralized applications. There is a very simple piece of a block scanner that I have written in. This works really well inside the Lambda. It actually utilizes the contract, where exactly the contract is deployed onto a chain, and how I'm just scanning from the last previously scanned block to the current blocks, and check for the which events that I find, and do something based on that. There are some, this whatever that I presented in terms of AWS serverless services like an S3, CloudFront, API Gateway, or the DynamoDB, or the Lambda. There are decentralized alternatives as well, but there is a learning curve. And many cases, if you do not want to, if there is no incentive to make a pure decentralized applications, you do not need this. There are alternatives, but you may not need it in all the cases. So it is good to actually create a hybrid Web3 applications, which has some areas which are purely decentralized, like a smart contract and other things. And there are centralized pieces like storage and the APIs and databases. Web3 is also move is current state is also slightly centralized. Like you interact with a standard software like MetaMask and Rainbow, you have to chain how you connect with the chain, how you present your transactions. That is right now there are popular alternatives like the Alchemy and Infura. There is no, these are the popular things. So without them, you cannot present your transactions easily. There are ways to present it, but this is the popular services through which you can present your transaction easily. Library wise, also there are, if you check, there are only two pretty popular web-based library, Web3 and E3JS. DNS has only one alternative, that is ENS, Ethereum Name Service. And the cloud wise, Arwave and Pinata is basically the popular Web3 cloud offerings right now. So it's also very specific. It's still, I call it still very early days compared to the current ecosystem of Web2. Many years of effort, many strong companies, product that we already have. Web3 is in very early areas. Things are changing every week. There is a new set of informations. The Anderson Horowitz just released the current state of crypto in 2022. It's pretty insightful. You should check it out. Salesforce just released the NFT cloud. I mean, Salesforce is a commercial cloud company. They just launched an NFT marketplace. So they must be thinking something that this space is growing in certain direction. That's why they are launching such a big product in this area. And the first one is just for the enthusiast on the Bitcoin space. That's it from my side. I'm slightly above the timeline, but if anyone have any specific question, I'm happy to answer it right now. Back to you, Ashirwad.
Thank you, Dhaval. And it was really insightful. I was not aware of so many things that are there out there, and we can build solution using this. I've been looking at the comment section for questions, but probably people are digesting all the content that you shared with them, and it might
It's
take.
still very early. Even I am also learning. I will call myself as a Web3 explorer. I'm a Web2 developer and a Web3 explorer. So it's very early. I am actually combining my previous experience with my current learnings and see how things are moving. So yes, if not right now, you can connect with me on the LinkedIn, other places. You can actually send me the questions there. Happy to answer. I share periodically. I share a bunch of information there.
That sounds good. So let's do one thing. So now that we are at the end of your session and we don't have any questions yet, let me announce the first raffle that we have. So whoever asks a question in the comment box and that question is picked by the speaker as one of the best questions that was asked. Obviously, all questions are good, they're great, but some are out of the box. And if you ask an out of the box question, you're going to get a JetBrains license from our sponsor JetBrains. So I hope you people now start asking more questions. With that, I'd like to thank Dhawal for spending some time on the weekend and hosting such a wonderful talk with us. It was really insightful, and we hope to see you in more of our upcoming events with Serverless Days and Utkal Techies Forum.
Thank you, Ashura. I'm sorry to take that extra few minutes. I understand we have to be on the schedule, but thank you. Thank you for the opportunity. Goodbye, everyone.
Thank you, Dhawal. And with that, let us get to the next session of the day, that is getting started with GraphQL and Azure Function. So let me add the next speaker who's going to talk about it, Anuraj. So welcome, Anuraj. So just to introduce you, Anuraj is a product architect at Soxo. He is a Microsoft MVP, as well as he is also an Azure developer community lead. So welcome, Anuraj. Super excited for your talk.
Thanks, Ashirat. I hope my screen is visible, or you can just.
Yes, it is.
Okay. So, hello, good morning, everyone. Like, let me introduce myself. Myself, Anuraj, as Ashirat mentioned. I work as a product architect at Soxo Solutions. We are building digital marketing solutions, and I'm a Microsoft MVP. So this session is about getting started with GraphQL on Azure Functions. So uh, here is the agenda. What we'll be talking today. So we will be discussing what is GraphQL and how we can get started with GraphQL in .NET, and we will be creating Azure functions with GraphQL support. And we will be looking into how we can work with data entity framework core and questions. So what is GraphQL? So GraphQL is an open source data query and manipulation language for APIs and a runtime for fulfilling queries with existing data. So basically, like most of the times when I take a session or when I discuss about GraphQL, people will ask question, okay, why we need GraphQL? What's the what's it is, how it is different from Rest, or is it going to replace Rest? No, it's not going to replace Rest. Rest is actually a architecture principle uh, or architecture but GraphQL is a like a language, or a, yeah, it's a language. So it's developed by Facebook in 2012, and now it's publicly released in 2015. Now you can get more details on GraphQL, graphql.org. So uh, again, the question is why we need GraphQL. Uh, we already got REST, which is a good thing. But the advantage of GraphQL is, for example, if I am calling a REST endpoint with which returns, say, person's information, and in case of REST, when we are getting a person's data, we'll be getting whatever information from the server, which is sent by the server. For example, if the server is returning name, email, address, uh, or profile picture, all those information, we will be consuming all that thing. There is no option. Okay, I need only name and email. There is no filter options unless the server is giving an overload or option. Okay, filter it like this. But in case of GraphQL, the advantage is there is no overfetching or underfetching. We can say, okay, I need only name and email. It will return only name and email. I will show you a demo. And another thing is, in REST APIs, we will version things. It's a we need to version, because otherwise there is a chance of breaking old clients. But in case of GraphQL, there will be like the only endpoint will be slash GraphQL or whatever. There will be only one endpoint, so we don't need to like uh, introduce versions. And if we are deprecating, we can show a warning, and clients can change that. And in future, like future releases, probably we will be able to remove that field or query. And uh, another advantage of GraphQL is, if we want data from multiple APIs or multiple sources. For example, in case of a blog homepage, we will be displaying content header. There will be multiple widgets. For example, recent post, featured post, comments, all those things. We will be fetching data from multiple sources or multiple tables. And in case of REST, we need to call each and every table separately. So, for example, if in case of blog, the example I told, at least I need 5 or 6 calls to get the complete data. But in case of GraphQL, we can get all the data in one single call. We can specify, okay, I need this in the query, and which will return all those things. And there is one more feature, like the similar to the one. It is like there is a concept called data stitching. So you can request for multiple data and put it as one data set and consume it in the client. I'll be showing the demo for each of these things. Okay, so these are that's the difference between REST and GraphQL. So in GraphQL, there are mainly three operations: query, mutation, and subscription. I'll be discussing query and mutation in this session. Subscription is a little bit tricky with that. I never tried subscription with Azure Functions, but it works awesome in case of web API. So query is basically our GET request. Uh, when we want to get some data, it's a read-only fetch. Mutation is write followed by a fetch. That means post, put, delete, all those things handled by mutation. And subscription, basically, it is like, instead of we calling, if something got changed and we want to get that data, instead of we calling the server, server will push that data to us. So we need to subscribe, and GraphQL server will push that data to us. So it is actually achieved using WebSockets. So and in case of if you are building subscription in Web API, you and deploying it into server, particularly in Azure, you need to enable that WebSockets. Otherwise, it won't work. WebSocket support we need to enable. So yeah, let's look into okay, for building Azure functions. In this session, I am using .NET as a language, and in .NET to uh, consume or to work with GraphQL, there are multiple packages available, but I am using a package called Hot Chocolate. Uh, First, okay, let's jump into a demo. So here I am creating a uh, web. So, empty web application, and I'm opening it in. I just want to show how GraphQL works, how we can get started using GraphQL, all those things. Okay, uh, it might take some time since I am sharing the screen. And here I'm adding the hotchocolate.asp.NET Core app package. Uh, and I'm creating a new file, query.cs. It can be anything. File name. I'm just putting query so that it's a get thing. So in this, I'm creating a class as well. Public class book. Uh, I got IntelliCode. That's why I'm getting a lot of suggestions. Sorry, GitHub Copilot is on. So here I am putting public uh, book, get book. Thanks to GitHub Copilot. So now I need to put add query. Now we are ready. I just need to run it. You can by default hot chocolate with a comes with a client, and if required you can use Postman as well to get the uh, okay. Let me 1 second. I think I missed some statements. No. In query also, I don't have anything specific. Uh, I'm not sure. I use the right package. Same. Okay. In program, algorithm, and GraphQL. Okay, I think GraphQL. So I'm running it. By default, it will come to stash, which is okay. And I'm saying GraphQL. Now it will load. This is the client which comes with a hot chocolate. I can click on browse schema, apply. You will be able to see whatever, like this is a query object, and this is the data type. And you can, this is like a swagger definition, and you'll be able to see the definition, what all things are there, what is the type, all those things. And in operations, I can say, okay, I want to get books, so I can say book. And if I want to get title only, I can do like this. It will return only title. And if I want to return author, I can say it like that. So, in case of mobile clients or low for factor clients, uh, you don't need to consume all the data. You might trigger only a set of data. So that kind of scenarios, uh, GraphQL is the best option, because in case of REST, if building a REST endpoint for like for the same thing, you when I request for a book, it will return title and author. There is no option to return anything specific. Okay. Uh, So that's the way we can get started with hot chocolate in GraphQL. Mm, okay, I already got some code. Uh, okay, this is one of the REST API examples. I converted that API into uh, this one. Uh, GraphQL, but it is a function, so uh, I will come to that later. Uh, okay, to this is the way you need to add GraphQL server and add query type. If you are creating mutation, I will show you a demo. You need to add mutation, and in the app you need to map GraphQL. So by default, GraphQL is running under slash GraphQL endpoint. But if you want to change, it's again related to API. You can specify the endpoint here. So if I change, I can put the endpoint here. If I want to change something like Swagger, if I want to change it, you can do it like that. Okay. Uh, yeah. And this is the only package I used, and GraphQL able we are able to run GraphQL. Okay. Yeah, this is the Hello World demo. Okay, let's get into creating function with GraphQL support. You can create a normal function and follow the procedure what I did earlier, like install the GraphQL dot sorry hot chocolate dot ASP.NET Core package and modify the function. But here, what I'm using, I am using Hot Chocolate offers templates for functions and all. I'm using a hot chocolate template. I just need to say .NET new install hot chocolate templates, and once it is done, uh, when I say .NET new list, here I can see hot chocolate GraphQL function and GraphQL server. So these two templates are available. Uh, I can create GraphQL function and server using command line. I'm using this approach for creating functions. It, it is also available Visual Studio as well. That function. I create new project once I install the template. WhatsApp like GraphQL function and GraphQL server, both are coming. I created this function using uh, GraphQL template. Okay, and here it is same, nothing fancy or different. It's a normal function. There is a function class, and there is a startup class and a query. This is the default one when you create a GraphQL function using this command. .new GraphQL is it. So let me create. Again. So demo. One issue I found in this approach that uh, this when we use this approach of creating functions, sometimes the studio code doesn't understand that is a Azure function. So debugging will be difficult. So I for that purpose I used Visual Studio. But if you want, you can always run using func.start. And if you look into it, there is a startup class, and here it is adding GraphQL function, and here hot chocolate Azure functions, not ASP.NET. Sorry, my bad. It's Azure functions, and all these things, this function, these packages required uh, to enable startup for functions. Without that package, startup class won't be recognized. And yeah, this is required for functions, and this is for startup, the dependency injection, and this is the package we need for Azure functions. Sorry, GraphQL support. And here, similar way, add GraphQL function and query type. I'm putting a query, and in the query class, it is calling a get person, and it is returning a person name. And in this function, there is a run method, and again, it is calling execute request. So, which is basically invoking the support for GraphQL. So, let me run it from start. Like I said earlier, sometimes if I try to debug using F5 command, Visual Studio code doesn't recognize it as a function, and it will ask for what is the type of environment, that kind of stuff. Similar way, uh, I got a banana cake interface, and I can request for person name, and you will get Luke Skywalker. And if you look into it, it is like any other normal function. You will get the request and response, all those things here logged. Okay. Yeah, that's about getting started, creating function using hot chocolate template. These are the types of file it is generating. That's also done. Let's look into how we can work with data. For example, if we are uh, building any uh, real-time function, you need to use data. So this is actually a API. Uh, this is a REST minimal web API implementation. Uh, it is actually inspired. This is actually from this I got the uh, jobs data, and I can get some jobs. So for this purpose, what I did, I converted this backend of for this application is a JSON. I converted that JSON into a SQLite database, and I'm using SQLite here. You can use any database, SQL Server or anything. I just use SQLite for the easy purpose. And this template is also this function is also created by hot chocolate template. And in the startup, the same thing. And if you look into it, I am adding few more things: add filtering, projections, and sorting. So basically, unlike Rust, you we can like execute queries like, okay, if I want to get only specific, you can use filtering and projections as you realize. So it is like, if I want to use only one data, all those things, you can use projections. And sorting by order. And here I am using mutation. Basically I am adding jobs to the database. So for that purpose I am using mutation. And in the query, I am, if you look into it, I am here I injected the uh, database context here as a normal ASP.NET core stuff. Add DB context. I'm using SQLite. This code is for identifying the current directory where the database exists. And here I'm injecting the database context. And in the query, I'm injecting that database context. And in this, I got a jobs table. So query, yeah, this is the DB context, and this is the uh, job class. There is a table like that, and it's straightforward code. And here, if you look into it, I'm using projection, filtering, sorting, all those things. Let me run this application. It will fail because earlier I didn't kill the func.start. So we should we couldn't start the application. Now it's running. Let me refresh. Now, if you look into the schema reference, you will get you'll be able to see at different things, and you'll be able to see query and mutation. What is the mutation object or method? What are the uh, query parameters here? And jog by ID method returns a jog object. This exclamation uh, means it's a mandatory. It's not optional. uh, jokes, there is a method like that which returns a collection of joke. A random joke also returns without, it's also mandatory. So uh, this is the way we should return queries. So I'm putting a random joke. So type, these are the fields with an ID. I'm requesting it and I got one. I'm executing queries. I'm returning things, and there is another uh, random joke instead of random joke and jokes by ID. And here, uh, if you look into it, it is showing an error because it is expecting a number. So I can say it like this: number. That is a value or parameter name I gave. So it's a number. This is injected by a runtime, and this is the parameter. So it returns 187. Yeah. Let's look into these aspects. So there is another object, jobs. So I'm saying query, and I'm saying jobs. And here also, I can say type setup time. If I run, it will return all the things. And if you note, like the earlier version, I can specify where. So if I want to specify, it is like when we are doing Mongo, this is the type query is something like Mongo. Yeah. So here, so it is returning only general. So if you want to achieve something like this in with Rust, it is quite complicated because in case of Rust, we want if we want to like search a particular type or query a particular type, you need to specify a method in server, okay, which is type with okay, which accept type, and that is one advantage with this one also. Like in case of GraphQL, the advantage is it's type safe or strongly typed because when we are requesting, uh, okay, in case of Rust, you will be passing value like parameters as query string, right? But in case of and in Rust, you can pass anything because browser or anywhere there is no validation or we don't know, okay, what is the parameter type we are expecting in the query string. We can pass string or number. It will like it will be failed on the server. But in case of here, or not random job by ID, and I'm just saying string. And if I'm specifying number as hello, it will fail because specify the argument value doesn't match the argument type. Okay, that's that one advantage of GraphQL over Rust. Uh, if you look into it, you'll be able to see type in a different color because the type is a reserved keyword in GraphQL. That's why it is in blue color and other two are in pink like that. Okay. Uh, yeah. And to use entity framework or data in GraphQL, you need a extra package or chocolate data entity framework. And another thing I want to show you is, okay, if like if I want to get a random job on top of this, if I execute this, this will probably pay. Uh, this is a extra thing. It's called alias. If you run this, it is failing because GraphQL is trying to execute this in parallel. So to avoid this, what we can do, it's again something related to EF. You can push DB context factory instead of DB context, and you need to use this, use DB context, rest everything, and yeah, the instead of service, you need to change it to stop service. Now, if I run this, it should work properly. Yeah. So I got this one, D random joke, random. Okay. Yeah. Another thing with GraphQL is you can use paging. By default, paging is turned on. You just need to use this attribute. And now the query will be little different. Query. Uh, this is still showing because the schema is not updated. Once it is, yeah, schema is updated. Now, if you look into jokes, and you will be able to see page info, edges, notes. So page info, I can look for all these parameters, and in the nodes, I can get all those things. By default, the paging will be 10. So if I execute this, I got 10 jokes, and this is the paging info. And next page and previous, there is no previous page. Next page is there. So to get next page, I can say here after, and we need to specify this cursor. And like that, you can move. This is the way GraphQL paging works, because you just need to put this attribute, and it will automatically manage everything. You can put various attributes to this various parameters to this attribute, like what is the minimum page, default page size, maximum, include total count, all those things. I will include this as well. Okay. I need to update the schema. You can update it like this. Just need to refresh. Schema is updated. Now I forgot the, yeah, total count. So if I run this, total 379. That's the way total count works. You can put various parameters to it, and you can even implement your own paging if you want. These are normal things. I will look into the mutation. I mean, adding things. I just need to create a mutation class, and it is using the same stuff, jobs context, and in the context I'm adding in, and I'm returning. And in the startup, we need to include add mutation type mutation as well. It might fail because mm, I need to change it to scope service. Okay, and here I'm using mutation and add joke. So P P1, I'm just putting a number. This comma is not necessary. Punchline, uh, and type. And since we are returning, I need to consume that as well. If I am not consuming, GraphQL will show an error. So if I execute this, yeah, uh, okay, it's something to do with once again at dependency injection, something wrong. Uh, okay, let me start um, counting this. So basically, that's the way mutation works. Mm, yeah. Don't know. Something is not working. I think it is something to do with my entity framework configuration. This failing. Okay, basically this is the way mutation works. You like this is the code. I am passing job as a parameter. So I need to create an object of job, ID, punchline, demo, all those things I need to pass, and which is returning a job. That's why I need to consume it. Okay, that's the way. Sorry, I don't know why it is failing. It was working. Um, that's it. Any questions? Asirwa?
Hey Anuraj, that was a great session. Trust me, GraphQL. I have never explored GraphQL with Azure Function. I played with functions a lot, but that's one area where it's more like a gray zone for me. Thank you for sharing the insights, and probably I'll start playing around with it after the session. I think I just
Yeah,
have the right
thanks.
tools and content to do that. Thank you so much for sharing it. Let's wait for one more minute and see if there are comments. And people who are watching it live, see there is a raffle going on. Ask a question, and who knows? Maybe the speaker likes it, and you might get a JetBrains license. It's there for the taking. Take it. There's no. You shouldn't be hesitant to ask. Please feel free, and we have Anuraj for 50 more seconds, and drill him down. We don't mind, right, Anuraj? He is here to answer your questions.
Yeah.
Let's wait for one more minute, and if nobody asks, then probably we don't have an option apart from going further.
Yeah, like probably they can contact me in Twitter or anywhere, social media platforms.
Thank you so much for making yourself reachable, Anuraj. And people, if you're shying away from asking queries on the comment section, please feel to reach out, Anuraj. Okay, there's a question. So Hari Kishan is asking, what are the use cases for GraphQL?
Okay, so mainly I when we tried GraphQL, uh, mainly for social media kind of implementations, GraphQL is very like super and easy. We are actually like converted one or two of our APIs into GraphQL, and which is working nicely. uh, and most of this since Facebook is introduced this, it is mainly focused towards GraphQL, and I do see some implementations like microservices, uh, which GraphQL acting as a gateway or facade to the microservices APIs. So that's one use case. I'm still to explore on that aspect.
I
I
hope it
hope
answers Hari
I
Kishan.
yeah.
Yeah, so people are starting to ask questions. That's nice. That's nice. So, Hari Kishan, please feel to share your email address at the comment section, and if you're not, please feel to reach out on our LinkedIn page, and we'll be happy to share you a JetBrains license, a JetBrains personal license, which is valid for one whole year for any of the uh, JetBrains products. So we have the first lucky winner. Oh, okay, okay. Wait. We have one more question from Deborah Bose. Do we need to have versioning like REST API and GraphQL?
No, we don't need versioning, because versioning, uh, we are introducing versioning in REST API because to support new features, functionalities, and if you are introducing any new parameters, or if we are returning something new, all those things we require versioning. But in case of GraphQL, there is only one endpoint slash GraphQL, and whatever data we need, or we like, it's up to client. Okay, if like even though server is exposing xyz fields, I'm only using x field, I can use that. And there is some attributes like which helps you to deprecate, okay, which will show a warning, okay, this field is going to deprecate zoom, and client can work on that and remove that field from the query. So we don't need versioning in GraphQL. That's one of the advantages compared to REST APIs.
I hope it answers your question, Debarbrato. Okay, I'll be more transparent about how we are going to give those, subscriptions. So we had one subscription for each session that we wanted to award. Now that we have two questions in this session itself, so Anuraj, it's your call. Which question do you think should get the license? We are very transparent
You,
with it. So yeah.
yeah, you are putting me into a tough spot.
Your call, Anuraj. You're the one who makes the decision here. Debabrata or
Yeah,
Harikeshan, which question?
I go with the first question because that's the way we initially communicated, right?
Correct,
Hari Krishna.
correct. Okay, so Harikeshan, you're the first winner of the JetBrains license that we are offering in this particular raffle. So, Harikeshan, please feel free to reach out to us, and we'll be happy to share the licenses with you. And with that, I would like to thank Anuraj for giving his time on a weekend and helping us out. learn about GraphQL and its use cases and how we can implement it in Azure Functions. Thank you so much for your time, Anuraj.
Thank you, Asura. Thank you, team. Bye.
And with that, we'll be moving on to the next session. So the next session is by a wonderful speaker, Ambrish Ganguly, where he's going to talk about predicting red wine quality using deep learning and develop a function, develop a application using Azure Container Apps and Azure Kubernetes Service. So without further ado, let me add Ambrish to the stream. Hello, Ambrish. How are you?
Ha- Hello, thank you. I am good. How are you?
I'm doing good. Thank you for asking, and thank you for taking some time out from your schedule and taking part in our event.
My pleasure.
And
Yes.
Amrish, I'm really excited for this particular session because Azure Container Apps is something that I haven't explored yet, and this definitely sounds interesting. And with deep learning added into it, that's really exciting.
Yes. Yes. So, if everyone's okay, let's jump in.
Definitely.
Okay.
Uh,
I'll
yeah.
share my screen. Uh, so the screen is shared. Yes. You are able to see, right?
Yes. I'm loading it. Yeah. Now we are able to see
Okay.
it. So the screen is
Okay.
all yours, Ambrish. I'll be there on the
Okay.
backstage if you need any help.
Okay. 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 Thank you, everybody, for being with us in this weekend. So today we are going to talk about Azure Container Apps. So before we jump into the session, certain things I want to tell you is that there is a demo. There is code also associated with it, and it is in GitHub. I will share the link in the GitHub. So don't worry if you do not understand something, or if I am not able to make yourself understand. So the GitHub is there, and all the code that I'll go on explaining is in there, and the README is also there. So if suppose I'm not able to answer, so that is one point that we would be going and going forward and looking into it. Okay. So so just sit back and let's try to enjoy what is Azure Container Apps. So Azure Container Apps is very fascinating. First of all, it gives you that Kubernetes flavor, the container flavor, Bla- but you don't have to go into the Kubernetes and understand the Kubernetes. Azure is doing the backend for you. And what more is that yesterday I was exploring more. So they have added also Dapper with it and Keda along with it. So Dapper is something so you have two microservices and you want to communicate with each other. So Dapper helps you to do that. Maybe another session we'll talk about Dapper in detail. And Keda is auto scaling, event driven auto scaling. We'll see that in action also. So before we jump in, so this is the thing: build and deploy modern apps and microservices using serverless containers. So it is fully managed service serverless container service for building modern apps. So what I did for this demo is that instead of having some application like in Hello World or something, it's like suppose you are doing your own microservice and you are doing your own way of doing things. And then what I did was that I prepared a deep learning service, a deep learning microservice. So how do you do that? So say suppose you know deep learning and you know whatever thing, it doesn't have to be deep learning. You whatever service that you want to build, you can write your custom code, and you can write your custom code anywhere. So for that, what I did was that I went to Kaggle, and this data set is there called red wine quality. So basically, this red wine quality, what it is doing is that it is a set of uh, let us see what it is. So this one, and so this is a data set. It has got a lot of variables, and they have got certain variables. It's not showing it well. Oh, here it is. So these are the variables that are there: acidity, acid, sugar, or chlorides, sulfur dioxide, density, pH, alcohol, and ultimately what we have to predict is a quality. So basically there is a lot of input variables, and once you give the input variables to it, you get the quality of the wine. So that's about it. So I will not go deep into the code of writing this, but anyways, the structure I want to show you, just to give you an appreciation, is that you can do anything with this as your container apps. For me, I thought let's do a deep learning model. So what I did was that I did a Python notebook, which is basically I've imported some libraries and blah blah blah, all these things, and it is a TensorFlow app. And then what I did was that I saved the model in a file, and it is in an H5 format, which is H5 format is I forgot what the full form is. It's a very nice way of storing it in a very compressed manner. So this is a H5 format file that I have saved, and there is some pre-processing also involved in it before the data set is being used for modeling. I will not go into the modeling part because some of you may not be interested, but it is a very simple TensorFlow model, and you can write your own TensorFlow model. So the intention is that to show you that for container apps, you can do anything with it. For me, I thought let's write a deep learning thing. So all of it is saved, and the two files which are important for us is the model. This is I have saved it in an H5 format, and some preprocessor file which I have saved. So what I've done is that gone ahead and and now I made a Flux service out of it. So the Flux service, Flask is a very easy way of writing services in Python. So let's look at the Flask service. So this is a Flux service, and because we are going to use TensorFlow, and we are going to use Keras, which is from TensorFlow, and Pandas and Pickle. So it has got very simple things. One basic function called hello, and there is a predict function where we do a sort of prediction of the thing. Of we give this some values and we do the prediction. So this is our service. So all the code is in GitHub for this. So you can write your own service in any language you feel. I chose Python because there's a data science program, so that's why I choose Python. But the important part for the container apps is that this is all simple code. So for you, you can write any service. Now comes the interesting part. So I used a Docker file. So I created this Docker file. So this Docker file is very simple. We are using a very slim version of Python, and then we are using the requirements.txt. Requirements.txt has the dependencies for it. So these are the dependencies that we have for it. So basically for this project, I've got basically couple of things. One is this two files that I've used for the program, the Docker file and this app.py. The others are all documentation and some YAML files which we will use later. Okay. So this is service. Okay. So what we did was that now we will do Azure Container Apps thing. Okay. So the Azure Container Apps is a serverless kind of a container. So what I did here is that we'll go through the steps one by one. So I am in my Windows machine, a WSL installed in it. So here, if I do an AZ, I am in this subscription. So what I will do is that, so the first steps that you have to do for these container apps is that we have all the steps written also. It's all in GitHub. So this is in GitHub. So all the steps are written, so you don't have to copy or do anything, you just relax. So first I have to install the Azure Container Apps extension. So what you do is very simple. You just copy this and you just put it here. For me, I have done it. So most likely it will not do anything and it will say it's already installed and be silent about it. So it is doing its part. Okay. So it's already installed. It will be updated if available. Okay. While it does it, let's go. So we have to register the Microsoft app namespace here. So we'll copy this also. It is taking some time. Okay. Good thing it took 50 seconds. So this also, I think I have done it. So it should not do a lot of things. So while it is doing it, let's see what is the next step. Okay. So we have to register the Microsoft Operational Insights provider for Azure Monitor Log Analytics workspace. So we have to do this. And now the next steps, I will go through them. So this is the resource group that I'm going. The location is Canada Central. You can do it in any place, but make sure where it is available, because during the preview stage, it was not available in all. Now it is generally available, so it is generally available in it. So now then there is this concept of an environment in container apps. So the same containers can use the same environment. So this you can copy it, and these are the variables that I will initialize. Okay, let it do it. Okay, the next steps I have already done, but I will walk you through them. So the next step is that I'll create a resource group, and this resource group is already created by me. So what I have done is that I have gone in. For some odd reason, maybe because of the streaming, it is taking a bit of more time. So here what I have done, I have created a resource group. If I go to resource group here, I have created this resource group called Wine Group. So you can create also this resource group through this command. All of it is in GitHub. Next, what we do is create an environment. Okay, so we create this environment, and this is environment that is used by the container app. So different containers can also share the same environment. So this is the environment that I'm creating. So it will take some time. Okay. So while it is being done, so what we will do is that we are going to create an Azure container registry. So this command. So the Azure container registry I have already created. So I will go ahead and show you where is the Azure container registry. So this is the Azure container registry that I have already created. I have named it AG Wine ACR. And it is a place where I will store all the images. Okay. So within the Azure Container Registry, there is something called repositories where you can store all the images. Okay. For me, I have already pushed it because it was a large image, but you can also do it through this command. So what I have done is that once you have created it, you can log in to the Azure Container Registry. So let me also log in because I have to log in anyways. Oh, so it is still creating the log analytics workspace. So let it create. So while it is being done, so let's wait for some time. So so what it would do is that it would create a log analytics workspace as well as a container environment. So let's see. In the meantime, what I will show you is that this image has been already pushed. So so first what I will do is that I will log into this Azure Container Registry, and then I have created the red wine flux Docker image from my code that is there, and I have tagged it to this AG-Wine ACR is this azurecr.io / redwine flux v1. So what is there? So this image was already there. I had built it to redwine flux, and now I have tagged it. So you will see that this tag is there. This is the one that is there. Hmm. So this tagged image is already there. So you can do this through this command. Let us see whether it is already done. So it is already done. So let me just log into the Azure Container Registry. So this will log into my Azure Container Registry. And once I have done this, then I would push the this image into the registry. So this is the Docker push command that I'm going to use to push it into the Azure registry. So since it might take a lot of time, so what I have done is I have already pushed it for myself. So this is the one. If I go to this repository is already there, and I am already this image is already there with us. Okay, let us see whether its login is succeeded or not. Okay, so the next thing what I will do is that I will push it, which is already pushed into it. Then I will update the container registry to run in admin enabled mode. And then what I will do is that I will get the password of this AG Wine ACR, which is a container registry. And then once all of it is done, then I will create the container app. So this is the theory behind all these things. Once we are done with the container app, you'll see of how we can utilize it. Okay, login is succeeded. So let me go on and do this one. So why am I showing you all these things is that you can build your own microservice. I built a very custom microservice. Whatever I wanted to do, I could do it. So you can build your own custom microservice, create a Docker file, and you can do all these things. So it's already done here. So the next step, what I will do is that get the password of the Azure Container Registry. And then once we have done with all the hard work, then we'll create the container app. So if you look at the container app, what it is doing, it is having the resource group, it is having the container apps environment, it is having the image which we have seen, the registry server, the registry name, that is AG1, the password. And because Flask is using the 5000 port, I put it at 5000. And then what I am doing is that exposing it to the outside world through ingress. Okay, so previously those of you who have done Kubernetes, AKS and all those sort of things, you had to write an YML file and all those sort of things. Now we are not writing anything, right? So we are doing it all with one command. We are just providing with the image and that's it. So this is what we are doing. So this one is here. Copy. This is our final command and we will see the output in action. So let's wait for some time so that we can see that the container app is being created. So where it will be created? So I will go here, I will go to wine group and let us just pause for some time till everything gets created. Okay, so this is a good one. Complete one cloud scales challenge. Go ahead and do it if you wish. Okay, so you see now while it is being created, we can see the environment. We can see the log analytics workspace also been created. So we can have a look at it. You can also have a look at this one. Let us see whether this is okay. Container app is created. Okay, let us see. Where is my container app? For some odd reason, the machine has become a little bit slow for the streaming or something of that sort. Okay, you see the container app is being created. So let's pause for some time. So what we did was that we just created a Docker file. We created a Docker file and then pushed the image just as we would do into the container registry. And then we applied some commands. So creating an environment, the log analytics workspace, and by running one command, everything is done. And it is like the Kubernetes experience that we would be getting. So let's see the Redwine app here. So this is a container app that you are seeing. So this has got a URL out here. I'm just excited just to try it out here. So this is my application URL. So what I have done is that I have created a Streamlit UI app, which is basically like you do a React.js app and all these sort of apps. Is a very simple way of creating an UI. So here I am just creating an UI app to call the service. So the service name is this. And let's see whether we are able to call the service. So to call the service, so what we will do is that we'll just run the Streamlit app. And this is calling this service. So I have put the URL of the service down here. Okay. Okay, while it comes up, we'll see what is. So here's the container app, and you see that there are a couple of things. One thing that you would see here is that continuous deployment is also given. So that means that you can do continuous deployment from here, and it's fully integrated with GitHub Actions. So here you can select an organization. So my GitHub is Ambarish. So it's loading the repositories. So I have my repository known as some recipe or something, or MNOPQR. This one, the branches master, the repository source is Azure Container Apps. So what happens is that whenever there will be any code change, it will be deployed to this place. Okay. So this is done. Service principal start continuous deployment. So very integrated, this one. Let's see what it is doing. Since this is something of a bonus, it was not written in the first place. So this is done. So it's already done. So you see the workflow file has already been created. So I click on this, what it has done. Yesterday I discovered it while playing around with it. So CI/CD is already there in it, and you see so this is a new one. 25 seconds ago I've created this one, right? So this one I was playing around. So this one it has created, and you can see that GitHub Actions is already there. So if you change any code, it will be automatically deployed and everything. Everything is done. Fantastic. Okay. Okay. I wanted to show you something. Okay. So this one. So this service is already there. So I'll go to my Streamlit app. And I'm just running it. So this Streamlit is a very nice way of building simple apps. Hopefully I'm typing the right name. It's redwine.py. So it's like it will open a browser in which we can see the UI. It is taking its own time. Hopefully it will come up. So while it comes up, let us look at this. So this is how we can do CI/CD. Let's explore the other parts. So here you can see the containers. You can see the containers out here. So one container app can contain many containers. So this is a container. Okay. So this is a container thing. I can scale it. So this scaling can be done with KDA actually. So you can edit and deploy, and you can add the scaling rules. You can do a scaling rule here. It's as if the feeling is as if that I'm doing an app service, right? You can do scaling rule here. You can take a scale type. You can do HTTP scaling. You can say mine new rule, enter concurrent request, maybe 5. So this is how you can do scaling. And another thing that I wanted to show you is that there is Dapper also. Dapper means that say suppose you have two microservices and you want to communicate with each other. So that's actually quite cumbersome that you have to do. You have to have a message queue, a RabbitMQ or a service bus and all these things. It becomes very easy that if you use Dapper what it does, it deploys a sidecar container on with your container microservice, and those sidecar containers can communicate and help in that respect. So maybe we should have a separate session on Dapper on that. So where is Dapper? So that Dapper is integrated out here. So it comes with a lot of easy things, and that becomes for a developer to concentrate on the business logic, because business applications are quite complicated. So we can concentrate on the business logic, and all these other things like scaling, inter microservice communication, and all these things can be very easily done. So if it is enabled, then you can do all these type of other things that with Dapper. So we have to add the Dapper container app. Just wanted to give you a glimpse of this is done. Now let's go back to this thing. So what we have done in this is a very simple thing. So these are the things that we are showing you, right? So I can predict the wine quality. Hopefully it runs. So this person is jumping or whatever it is doing, and it is trying to go into this web server and trying to get the wine quality from these things. Okay, so it is 5.19, so you can change it, maybe make it the pH to 2. Yeah, so it's changing, and play around with this sulfur dioxide to. So you see, so this is a way that you can do these container apps. So this more or less completes the demo. So what we have seen is that we have gone ahead and created our own application. For me, it was a deep learning application. You can do your own microservice, and then you can take the microservice and build all these things out here and create a Docker file, and that's it. Create an image, and how to create an image and all those things are given here. So I will just tell you that if suppose you're a bit rusty of how to create an image, you can just do a Docker build -t red wine flux, that you can create an image, you can run the image in your local machine, and all these things that you can do. And then you push that image into the Azure container registry. So this is how you do it. I will take a pause here and see if there is any question. Um,
So Ambrish, I don't
Okay,
think we
I
have
will
any
also
questions
share
yet.
the private
Yeah.
chat, the repository, GitHub repository also, where all the code, the README file is there. So
Sorry, I
this
was
is a
on mute.
GitHub.
Yep.
Huh?
Please continue, Ambrish. I'm sorry to
Mhm.
interrupt.
So this one I will put it in the GitHub so that you can share it with everybody, the GitHub one. So this completes our Azure Container Apps. And before we go on to the Kubernetes, which is not serverless, but I want to show you so that you can make a difference. I would see that if you have any questions or not, I would be glad to take any questions actually. Okay.
Amrish, I think people might take some time to digest the content.
Ah, ah,
So
yes,
let's complete the Kubernetes
yes.
one and take a Q&A there.
Okay, okay. So the Kubernetes one, yes, absolutely, absolutely. Kubernetes one is actually we will do it. So where is my Kubernetes one? So the Kubernetes one, hopefully, the Kubernetes one takes actually some time to deploy. Let's see if I can complete this actually. So what it does is that we have the image in the repository. The where is the repository? The repository is the image. Okay, I don't want to do anything. Yes, absolutely. There is a lot of things going on. The repository is there and it has the image. So now you can use AKS to do all these things. Now, AKS doing these things in AKS is that you require an AKS cluster. Okay. So what we have to do is that we have to create a service principal. Okay. So this is our repository name. This is a service principal. And we get all these things like the housekeeping stuff. What is the registry ID? What is the password, username? And then what we do is that we create the cluster. We create the cluster here. And then what we do is that we apply this YAML file to do the kubectl. So let's see whether we can complete this. Otherwise, let's run the command and then I will explain to you what is the difference, and you will appreciate why this container apps is so very easy to do. So this one is the registry ID. So this registry ID is nothing but the Azure registry ID. We are just doing things a little bit programmatically. So registry ID is, if I echo that registry ID, and then you will find that it is this guy only, agwinecr.azurecr.io. Let it run. And then what we do is that we will get the password and the username for the registry ID. Okay. So this obviously might take some time. So while it is doing it, let me explain to you why. So we'll create the cluster. The cluster, the AKS cluster will be created. And now what we have to do is that we have to get the credentials of the cluster. And then, so when you're using Kubernetes, you have to do all these things. You have to write the YML file for that. So the YML file, redwineazure.yml. So here's the YML file. So whatever we had done through container apps, we have to write the YML file. So this YML file has a couple of things. It has a deployment section. It has got a service section. Now this deployment section has got 3 replicas. It will have the image and all these things would be there. And then there will be a service section, and then we'll have to expose this. So you have to write this YML file. Now contrast this with the Azure Container Apps. We are doing the same thing, we can do the scaling, we can do all these things. And Kubernetes also, the scaling, you have to do it yourself with KEDA or something. So there, it's writing the YML file is required in a case, but it's not required in the container apps. So let us see whether this is done. Oh, so this is done. And then what we'll have to do is that we have to create the cluster. So we are creating the cluster here. This usually takes some time. Okay, this will take some time. So after this, we'll run the credentials so as to get the KKS cluster, and then we'll apply it. So one of the things that we want to tell you is that if you are not concerned of going into the internals of Kubernetes, go ahead and do Azure Container Apps. And but if you want the inner details of how this, then go for Kubernetes. And Azure Container Apps comes with Dapper, with KEDA, with GitHub Actions, and everything bundled together, so that becomes easier for you. I need to investigate a bit more about speed, maybe about the performance, which is more performant. We'll have to see on that. So that's one thing that I am very interested on. So if you do all your experiments with these two things, do let me know also of how it is. And the GitHub repository is there. Please feel free to fork it or have a look at it. And so this is the thing that we are doing. And and another thing is that I have also a YouTube channel where I post things on data science as well as containers. So that is also, you can have a look. I'll also paste this if you like it. Go ahead and watch the videos. I'm not being very active nowadays, but I'll try to do. It's more of an habit to get into this stuff. So this Kubernetes thing takes a lot of time. Anyway, so all the code is in GitHub. So this will take a bit of time, Kubernetes cluster creation. And what then we do is that if you follow the steps, you will have to get the credentials here to get the credentials, and then you will do a kubectl apply -save redwine azure.yml. The redwine azure.yml is here, and what it does is that it is doing a deployment as well as it is creating a service. So what you do is that you take the service and you can use it in your applications later on. So this is what I'm sure that if we have some time, we can do it. But if at all we do not have time, then this is what I wanted to show you in this whole thing. So please, if you have any questions or anything, do let me know that.
Yes, people,
We
if you
can
have questions,
see
please let
that
us know.
we can.
Oh yeah, we have a question. It's from Harikishan. So, what are environments in AZ Container App?
Yes, there is one question. What are the environments in AZ Container App? So, so the environment is a place where you can run the application. So here is the environment. We'll show you the environment here. And several containers can share the same environment so that I feel it's more like an isolation boundary in which you can do a lot of things. So there is not much that we can see. Um, so uh, so this is a kind of an isolation boundary in which not only one container app can be there, but different container apps can also be there. So do check out the documentation. It has a very nice figure in which not only one container app is being hosted in that environment. You can use this environment to do all those things. Let me just find out to show you the figure. Yesterday I was looking at that as your container apps environment.
In the meanwhile, people do share your feedback about the event, about the sessions, about the speakers, so that we can also let them know. You can let us know how we can improve further when we organize the next edition of Serverless Conf, and happy people back here to share
While it
knowledge
comes
and
up,
great.
yes, sorry. Yeah. Mhm.
Yeah, Amrish, I'm done. I was just saying that.
Yes. No. I interrupted you. Rather than me saying this, there's a very nice schematic out here. And let me see if there is any more question. There's no more. That's fine. So,
Yeah, yeah. Let's wait for one more minute because
unfortunately,
we
the
got the
machine
question at
has
the last
gone a
one
bit
minute.
slow. Hmm, hmm.
I
Hmm.
think there are no more questions, and if there
So,
are no more
so in
questions,
summary, uh,
please say, Amrish.
so in summary, yes, so in summary, why container apps, that is what we were saying, is that it becomes very easy to deploy and all those things. And, and, um, and you need not know a lot of Kubernetes, and it comes with all this SCADA for scaling, Dapper for inter-service communication, as well as GitHub Actions. So, so these are the things. So you see here that this is isolation boundary for the container apps, and you see there is a container app 1, container app 2, and you can have different revisions of the container apps. And what more is that you can also have same revisions, different revisions of the same container app, different revisions of the container app 2. And there is good documentation that when you should use the same container app, uh, all these type of things are there when you are having the applications uh, communicate with each other using Dapper, and all these things have the same log analytics workspace. So this is very good documentation why this environment is useful. And I find that somehow the challenges that we faced when deploying the Azure Kubernetes services, and if it is a very complex business application and you did not know a lot about Kubernetes, you can go in for an container apps. It's in GA right now, so I'm not sure whether how many people have really used it in production, but it would be very interesting to see that how this landscape is changing with Azure container apps. And another thing is that if you are interested, do check out. I did check out, but I was not unable. I was unable to do it completely. There's something in preview which is draft. Draft has come up with Azure Draft, to check out that. That itself is that we did the Docker file ourselves. There we don't have to do the Docker file. So that is all the more interesting. That is very, very interesting. That is coming up. So basically, the infrastructure part and everything is becoming very easy nowadays. Is I think it's more or less done. So that's about it from my side. Um, Thank you everyone for listening.
Thank you so much, Ambrish, for taking some time out on a weekend and sharing all the insights that you gathered, and you shared it for free with us. Sheldon may get all this information at one place, and thank you for making the session more resourceful and engaging for the whole team and the attendees. And Harikishan, I'm sorry to say you got the subscription one, so I will not be able to give it to you one more. But the thing is, you can still share your feedback, and people, whoever is watching, please share your feedback. It's really important for us to improve further. And just to add on to that, we have an incentive to it as well. Some lucky winners are going to get some Microsoft branded goodies from our supporter Microsoft. So please feel free to share your feedback and get some goodies. With that, I'd like to thank Ambrish again, and
Thank you. Thank you.
thank him for his time. And we expect that we'll get him for the next edition of the conference as well. And with that, let's move on to the next session of the conference. So that's the final
Yes,
one.
thank
And
you.
thank you so much, Ambrish.
Bye.
Bye. Have a good day. And with that, let's move to the next session, which is running containers on Azure Functions. And for that, we have Abhishek Mishra with us. So Abhishek is a C# Corner MVP. He's a principal architect as Citadel Tech, and we have been co-authors of a book on Azure Function, which is hands-on Azure Function with C#. So welcome, Abhishek.
Hey, hi Ashirбад. Thanks for this wonderful opportunity in serverless to speak at Serverless Bhubaneswar. So,
The
like,
pleasure is all mine.
thank you. So, am I good to start? I can share my screen.
Definitely.
Okay.
In the meantime, folks, the feedback links is there in the comment section. Do give it.
Do let me know once my screen is visible.
It is visible now.
Okay, cool.
Okay, wonderful. So we are good to start. The screen is all yours. Let me know. I'm there on the backstage to help you with any technical problems.
Yep. Thank you. Hey, hi all. Today I bring you one exciting area like how to run Docker containers on Azure Functions. Note, I'm not talking about KEDA, like running Azure Functions in the Kubernetes cluster. It is there for a while, but we'll talk on a lighter area, like where actually I'm going to containerize an Azure Function app, an Azure Function basically, and run it in the Azure Function app. So let's get started with that. So before that, let me give a quick introduction of myself. I work as a cloud architect and have deep industry experience working for top IT companies and large enterprises. I have been doing digital transformations for large enterprises, leveraging cloud and artificial intelligence for my customers across the globe. I'm a published author. Few of the books are there on my screen, like Mastering Azure Serverless Computing, Mastering Azure Kubernetes Service, Hands-on Azure Functions with C# that I co-authored with Ashirvad, and Hands-on Azure Data Platform. Apart from it, I'm a passionate researcher, and currently I'm researching in the field of digital transformation in healthcare. Okay, so let's move on to the agenda. I have kept the deck very light because we'll be doing a lot of demo. But before getting into the stuff, let's first understand what the business case is, why we need it in the first place, right? Because we need to understand why we need to do it before we start doing it. So that is why we'll start with the business case. I'll introduce the business case to you so that you get familiar with when to tackle such kind of things, or when to bring in this kind of an implementation in my environment. Okay. So let's start with the business case. And so here I am So it's a bank scenario, like a cool bank and co. The client CIO has come up with a requirement. The bank has formed a strategic team, and they will be building some common utilities that can run on cloud in a serverless mode. This is more important. They want to run those common utilities in a serverless mode on the cloud. So it is basically, it's a strategic team or a capability team that is building cloud tools that can be used or leveraged by different IT projects in the enterprise. So when we talk at an enterprise level, so it may comprise of lot of projects, right? So for example, like suppose you're working in a organization, so in a, say, BFSI unit. Okay, the BFSI unit or the banking or financial services unit of your company will have a small unit that will be building the common utilities, and there will be different customers for that BFSI unit. For example, like maybe clients like ABN AMRO, or like State Bank of India, ICICI Bank, or like some international other international customers. Like you'll have lot of customers around you. Okay, and for each of these customers, this small strategic unit will be building common utilities that can run on the cloud in a serverless mode and give it to them. And what is the advantage they'll get with this kind of a mode? So like, or this, with this kind of a distribution of the common utilities, the different IT projects will not be building those things from scratch, rather use those components, and this will accelerate their development, and the project completion will be quick. That means you give liberty to your customer. Okay, in those same scenario, like Mr. Client CIO from the cool bank and co has come up with the requirement that they have their own strategic team, and they have different projects running in their bank, and all these projects will be leveraging the common utilities that is built by the strategic team. Okay, and one more important thing is that each of the project will have their own cloud subscription, and they're supposed to run on their own cloud subscription. It is not something like the strategic team will be hosting those components and will take all the cost, because when we deploy something on cloud, we have a ownership cost, right? A total cost of ownership, a TCO is associated with it, and that strategic team doesn't want to take that cost with them. Rather, they want to like give it to the different projects, and or rather distribute it, package it, and distribute it to different projects. Different projects will take those packages, and they will host it in their own cloud subscription. And most importantly, the bank has partnered with Microsoft for Azure. Okay, so Azure is the choice of cloud for the bank. Now let's see how the solution goes. So this is an enterprise architect from the Awesome Services Limited. So he's engaged with the bank to provide a strategic solution for this, like how to like help the enterprise, or rather the strategic team package the utilities and distribute it across the projects. Okay, and what he says is, he proposes like containerizing the utilities, keep the utilities in Azure Container Registry, and then the from the Azure function we can pull these containers and run it, right? This is very much we do with containers, right? So like I'm not getting into depth of containers or Docker and all, because like they're pretty much there from a pretty long time, and you all must be familiar, I'm pretty sure. So I'm not getting into those concepts, but rather, like I'll just hint on it that when we say containers, so we build or package our application along with all its dependencies, and we keep it in a centralized container registry. It can be a public Docker registry or a private registry like Azure Container Registry, and then we keep distributing it, those container images, in different environments, right? From the dev environment we can pull the container and run it. In the test environment we can pull the container and run it. In so way, like there are different ways of running the containers or the target environments. uh, you can leverage the containers that is kept in the Azure Container Registry for running all these things. Okay, so that's what we are going to do today, like in the demo. So we will actually implement what this enterprise architect is proposing for the use case provided by the bank CIO. Okay, so we will containerize, we'll actually build a small Azure function, we will containerize it, And once you have containerized it, we'll be pushing it to Azure Container Registry and then run the containers on Azure Functions. So these are the pretty much things we are going to do. And let me now start with the actual action, and let's see what we need to do. Okay, so before you start doing this demo, or like you get your hands dirty, these are few of the prerequisites that you need to have. Okay, so I'm not going to get into an Azure portal to create an Azure function today, because in your production environment you hardly do it, right? We automate everything, like we write infrastructure as code scripts to spin up the environment, spin up the cloud resources, do the deployments through like different automated ways. We hardly spin up anything from portal. But again, like few things I pre-created, and for for the demo purpose, I will just show you the portal with the functions and all those things created. So we will be using Azure CLI for pushing the Docker image, I'll come to that. I am not going to use any Docker commands to push a Docker image. Rather, we are going to use ACR build command to push the Docker image. So we'll be using for that. We'll be using Azure Function Core tools for creating an Azure function and containerizing it. You need to have an Azure subscription with you, and most importantly, Visual Studio Code, so that you like whatever code we are generating using Azure Function Core tools, we should be able to edit it using Visual Studio Code. Okay, and what are the steps? I'll just reiterate it. I have already told you in the previous slide. So we are going to create an Azure functions locally using Azure Functions Core tools. So we will use Azure Function Core tools to create the Azure functions locally. We will containerize and push to Azure Container Registry using Azure CLI commands, not Docker commands. Okay, because when you're doing the Docker commands, you have to execute a series of commands. You get saved from all those things. No need of writing so many commands to push your container image. Rather, with a single ACR Azure CLI command, we will push it. Okay, we'll see that. And then we are going to host the container on Azure Function, and finally we'll test it whether it's working fine or not. Okay, so let's do it. So I have documented the steps here. So like once I complete the demonstration, I will share the steps with you. So as of now, what I have done is, let me go to the Azure portal. I have created a resource group already. Okay, inside that I already have a container registry created. Okay, but creating a container registry is very simple. I'll just quickly show it to you how to create it. But I've already created it beforehand because I need to do the session in 30 minutes, and so like I need to have something beforehand already created to help that. Search with container registry. Okay, and then just need to do a create. Provide the resource group where you need to create it, name of the container registry, and the SKU. So basic or standard, something you can use. But anyways, I've used standard. I'm not worried. After the session, I'm going to delete the entire resource group, so I won't be charged much. Okay, so like this is how you can create a container registry. And I already told you I have already created a container registry that I will be demonstrating. Okay, now let's get into the steps. Okay, so first step, I need to do a AZ login. Let me do that. We need AZ login to log into the Azure environment, right? So pretty much everyone knows this, so not worth of repeating this and or explaining what AZ login is. Okay, and you can see I have multiple subscriptions with me. So I need to select the subscription where actually I'm going to do some actions, right? So this is a subscription, and this is a subscription ID. I'm using AZ account set command to set the subscription. So let me do this. Okay, now I'm good with it. What else I need to do now? or what I need to do now, I have already logged in. Let me start creating the Azure function. Let me create a directory, say like mkdir serverless demo cd serverless demo. Okay. So inside this, so I need to initiate the runtime. Okay. So I'm specifying with this command. You can see I'm initializing the runtime for the function as .NET along with a Docker file. So this will get generated. Okay. It takes a while. See. So once it ran successfully, so this is our folder. You can see a project has been created here. Okay. A project has been created here, or your function has been initiated, your function code has been initiated, and you also have a Docker file created. Okay, we'll see that in a while. We'll open this in VS Code and we'll see that. Okay, so what is the next step I need to do? I need to create a function, okay, with HTTP trigger. Let me name it as serverless func. Okay, or let me name it as serverless func. Func new hyphen name, and it's an anonymous access. That means I'm not enabling any kind of authentication right now. I want to keep the things simple. Let me do this. Okay. So, okay, now it's created. Let me open Visual Studio Code. Let me open folder Serverless Bhubaneswar, Serverless demo, select folder. Okay. So this is what has been generated for me. You can see a Docker file. One sec, I'll just. Okay. So you can see a Docker file is created. Okay. It is using a standard .NET 6 SDK 6 image. Okay. And then it is like copying the SDK into those .NET folders. It is doing all the run stuff, like all or normally whatever you have in a Docker file to build your image. Okay, I'm not going in details in this. And also it has created a function file, serverlessfunc.cs. Ignore those errors because it's the VS Code is not configured for C#. Currently, I'm working on a book for Java, so I've only kept the Java plugins in this, and I've disabled all other plugins. So apologies, you can see this error, but you can ignore this. Absolutely no issues. Okay, so this is the normal the normal function that we get, right? When we create a function from the portal, this is a function code, C# function code that we get normally, right? Using the C# script. Okay. So what I'm going to do here is I'll just append a name Docker here so that I know that this is running from the Docker. Okay. Here also I will append Docker. Okay. Now I will save this. That's it. Close this. Now what next? Okay. I have created the function. We saw that in Visual Studio Code. We generated it using Azure Function Core Tools. Where once you install the Azure Function Core Tools, you will get all these commands, these func commands. Okay. Now what next? I need to build it, right? And push it. This is the command. If you remember, if you have ever done Docker stuff before, so what we do a Docker login, we do Docker build, right? We tag it with the repository, then we push it. We do so many commands there, Docker commands. Okay, so AZ-CLI has come up with this AZ-ACR build command that will help you to do things in magic, or rather it's pretty quick, it's magic. It will build it and push it in one step. Instead of running so many commands, you just need to run a single command. Okay, maybe I'll call it the image name as agscr build -t dev01 colon dev. Okay, this is the tag. You can target tag it with the version number, or like you can also tag it with the environment. Normally either ways you can tag it, so like there is no restriction in that. Okay, and this is the registry that I have created. I showed you when we started with the demo, I showed you one Azure Container Registry, right? That I created earlier to save time. This is that registry that you can see here. Now let me run this. This is going to build and push. Okay, it will build the Azure functions image, container image, and then it is going to run all those Docker commands in the background. Okay, you'll see that those commands here. See, it has started pulling, started the Docker steps. It will build the Docker image and it will push it to Azure Container Registry. So one takeaway here, very important, HEACR build, you can use that if you're working with the Azure Container Registry as your to keep your container images or Helm charts. Okay, like you can use this HEACR build to like build a Docker image and push it to ACR. No need of running so many Docker commands, guys. It's so simple and easy. You should actually try this. Like after the demo, I would strongly encourage you to go back and try this stuff. It would be pretty interesting. Still some steps to complete. Let's wait. This push activity, it has started pushing it to this container registry, you see. So it's in progress. Okay, it's done. Let's see whether we have it pushed or not. Let me get into the repositories. And I see here like demo 01, correct? We have pushed it just now. We built it, we have tagged it as a dev, and we have pushed it. Okay. So now let me run this image in our Azure functions. Okay. I've already containerized it. I have pushed it to Azure Container Registry. Now I am going to run this image in my Azure functions. So let me do that. Okay. Let me go back again to my manual. So first, like before we create an Azure function, I told you I'm not going to do anything with or I'm not going to create anything on Azure portal. I will do the way we do in production. Okay. So what I'm going to do, I'll run this AZ command, Azure CLI command to create a plan. Okay. I will call this plan as maybe my serverless demo plan. Okay. My serverless demo plan, location East US. It's a Linux based environment. And one important thing, this particular thing won't work on your consumption plan. You have to use a premium plan. Okay, so be careful about it. That's why you see the SKU as EP1. It's a premium plan, so it won't work on the consumption plan. You need to use premium plan to work on this as of today, because like Microsoft services keep evolving. Now let me create this function app plan create. Let me just, this is the resource group, this is the name of my plan. Do an enter. While it's creating, I will explain you what I'm going to do next. Once this plan is created, I'm going to create my function. Okay, the name of my function would be maybe I need to give a unique name. I'll just put a 01 here. Okay, my func 01 to 2810. Then I need a storage account. I have already created a storage account, because we know, right, when we create Azure function, we need a storage account, like we normally associate it with it. So when you're creating from the portal also, they'll ask you to create a storage account. Okay, so I've already created it beforehand, and I'm mentioning it here, the resource group. Then I need to call out the name of my plan. Okay, my serverless demo plan. Then I'm saying that I'm going to deploy from this Azure Container Registry, and I've provided the credentials of this Docker registry. Okay, so one important thing I'll tell you. You can see here I'm using these credentials, right, for pushing it to SCR. So where did I get these things from? Let me show that to you. But if you don't want to use it also, there are other ways. Like, I'm not discussing it here. Maybe at some later point of time we can explore what are the other ways of integrating container registry with this Azure function. But as of now, I'll just show it to you from where I got all those things. Let me go back to my Azure Container Registry, access keys. Okay, I have enabled the admin user here, and these are the admin user credentials, whatever you see here. If I go back, you see here this SCR serverless demo, the user name. This is the username, and this is the password that I have provided here. Okay, and what it is going to do is, once we are done executing this command, once your function app is created, you can go to the environment settings, and you can see these the values of this of these environments. I'll show it to you once it gets created. It will be there in the environment variables of your Azure functions, or rather your configuration settings. Sorry, these values will be stored, and the function would be able to see that, or use that. Okay, my plan is created. Now I'm going to create this. Let me just leave. Okay, it takes some 2 to 3 minutes, so by then I can take few questions actually. If you have any questions, Ashirba, do you have any questions on the screen or no? Hello.
Oh, sorry. Probably I didn't add myself on the screen. That's why the audio didn't
Okay.
come. So we don't have any questions as of now on the comment section, but let's wait for the end of the demo, and after that
Yeah.
we can have 5 minutes block just for the Q&A. Sounds good?
Okay. Yep. I'll need another
But
5-7 minutes to complete this.
that's fine. That's fine. We can extend.
Okay. Thank you.
Thank you.
So let's wait. It's actually going and creating the Azure function in the portal. So, oh, cool. It got created. Let me show it to you. So I need to go to the resource group. Let's see that function, what has been created. Then we will test it. Okay. This is the function we created. My func 012810. Okay. So let me show you the configuration settings. Okay. You see here, this Docker image name, password, URL, everything has been populated here. From where did it get it? It got it from this command. When we pass those commands, okay, when we passed those these values against this Docker registry server password or Docker registry server user, then we got all those values. Okay, it populated it from there. Okay, and what next we need to do? Let's go to the functions and let's see. Okay, hey, one thing I just what I did was, so the name of the image, okay, I am pointing it to a older image like demo, but actually I should have pointed it to demo 01. Okay, I should have pointed it to demo 01, so that we built. but that's fine. We have already created it. So it's pointing to another container that has been containerized. Okay. So, but when you are doing it, you just need to just remember that we need to provide the name of your container image and the tag that you have containerized and kept it in your Azure container registry. I just realized it. My apologies. So this is your container image name. Okay. Now let me go back and see what it has created in the function. It has created a function demofunc01. Okay. So now what I'm going to do is I'm going to run this function and let's see the output. More or less we'll get the same output for what we had containerized. Okay. Func01. See Docker. Okay, there also when I was prepping up for the demo, I containerized that image. Okay, so even there also I'd appended this Docker string, and if I pass thing like name equals Abhishek. So hello Abhishek. This Docker again I had prepended like the one we did for the current image we containerized. Okay, so that was a full story of like how we can build a Docker image, or rather containerize an Azure function, or run, or basically to keep it very simple, how we can run Docker containers on an Azure function. It's a pretty simple thing, but a powerful thing where you can actually distribute your Azure functions as Docker images so that it can be reused across other components in your project or across the enterprise, or globally also you can distribute. They can just take it, use it, bake it in their subscription, or host it in their subscription, or use it other way around. If we did not have this kind of functionality, if I go back to the old use case, then the team that is building those common utilities, they would have hosted it, and they would have worked on a charging mechanism, and again there will be some chargebacks that again will be a additional responsibility for your for that strategic team which is building those utilities. And another area where this can be used is, so I can give you an example of one of my projects that I did in 2017, but not on Azure Functions. It was on an AKS. So actually it was in web app, container on web app. So what happened was the web app wanted to use some Python components. Okay, by default, when I'm using or deploying my code on Azure Web App, my .NET Core code on Azure Web App, it cannot invoke the Python components by default. Okay, for that, what we did was we containerized those Python components along with the .NET Core Web App, and we call those Python components from the .NET Core Web App. Okay, like for example, if you have any customizations to be done in your deployment, Docker is the best way, whether it is for Azure Web App or Azure Functions, so you can use it like a charm. And most importantly here, you build your image once, take it to different environments, just change the settings, the environment settings or your environment specific settings, and make your application up and running. So that is the beauty of Docker. And there are so many other advantages associated. I'm not going to talk it all in this session. So that is pretty much. So if you have any queries, then I'm open for a Q&A.
Hey Abhishek,
Ashirvad?
I think the demo was great, and I think there's one question.
Okay.
Um, it's from Ashish. So he's
Okay.
asking us, how about Kubernetes implementation in a container?
Yes, that is a pretty interesting area. So we can also run Azure functions in a Kubernetes cluster. For that, you need to use Kubernetes event-driven autoscaling, KEDA. Okay. So using KEDA, what you can do is you are going to use the same set of Azure function core tools, okay, to containerize your your Azure functions. Instead of putting it in a Azure function, there like you will be hosting. There are a separate set of activities that will help you and guide you in running those Azure functions in your Azure Kubernetes service. And that's a very important thing. If you're working on Azure Kubernetes service and you need to bring in serverless Kubernetes or the serverless way of working with or rather running some serverless components in Kubernetes, okay, so this is the gateway for it, like Azure functions, because Azure functions itself are serverless components using event driven auto scaling, so they can scale like anything. So whenever your incoming load increases, KEDA will make sure that it can scale rapidly, your function can scale rapidly, your function can handle those kind of request in a serverless way. Because when we say serverless, two things: we save on cost because whenever the code is running, then only you get charged. Second thing is whenever any incoming load comes, it can actually, it is elastic to it actually, so it can scale automatically. And once it scales, it can bring in, it can come in automatically. No need of doing any automatic scaling, automatic or any manual scale settings for it. So you can use KEDA to run Azure functions in Azure Kubernetes service. Maybe sometime I should do this on this platform.
Definitely, we'll be happy to host you.
Yep.
Yeah, thank you, Ashish, for bringing up that idea for that question. We have a new session next month, maybe, or some other month, depending on Abhishek's availability. So, if there are any more questions, guys, please feel free to ask. We have one more JetBrain license to share, and you have one more to take. So please do ask. Abhishek is our expert. We have him for a couple more minutes. Any queries that you have, you can just ask him, grill him down. He's there. uh, if there are no more questions, I would request you people to fill in the feedback forms. The feedback forms are really important for us because it will help us understand what we did right, what we did wrong, and how we can improve. It's really important for us and for other people as well. So there is one more question. I think it's a
Yep.
question from Harikishan. He's asking
Mhm.
running Dockerized AZ function in AKS.
Yep. Yeah, for that you need to use KEDA, Kubernetes event driven auto scaling. So
I
the
hope
same
it
thing.
answers her.
Yep.
I hope it answers her question. So let's wait one more minute because we have seen that questions were coming at the very last moment. So let's give it one more shot, and then
Yep.
probably we can give the subscription that we have to share. Uh, Guys, please feel free to ask questions. It doesn't cost you anything to ask questions in the comment section, right? Just ask it. And I don't think we have any more questions. So Abhishek, I think we have already shared one license with Harikishan, so he's not eligible as per the rules. So
Okay.
Ashish, congratulations for the JetBrain license, and please share your email address with us on my LinkedIn channel. You can just share your email address, and I'll share it with you. And apart from that, Abhishek, would you like to share some resources with the attendees that they can, use?
Yeah, for this actually, so the best resource for AK's thing is our book. Like um, me and Ashirwad, we co-authored a book, Hands on Azure Functions using C Sharp. There actually we have very clearly demonstrated how to run Azure functions inside a Kubernetes Azure Kubernetes service. And also, like, for today's demo, maybe I'll just share a Microsoft link. But again, like, they're using Dockers and a lot of other things, so it's not as streamlined. But again, like, you can take it as an inspiration. I'll just pull that uh, Microsoft documentation. Maybe I'll share it to you offline, Ashirwad. Maybe you can post it.
Sure,
Uh,
sure, that
yeah,
works.
yeah. So, like, actually, what in that documentation, Microsoft documentation, what they have done is they have taken a simpler approach. So they have containerized an Azure function, the same use case. They have solved the same use case. They have containerized the Azure function, but they're using a set of Docker commands. And again, they're doing it in the Docker Hub. Okay, they're not dealing with a private registry, because you can't take that solution to your production scenarios. Okay, because there we have restrictions, right? So you can't
Correct.
you pull an image from a Docker Hub and use it. So what I've done here is, so like I have demo used that AGSR build, the new AGCLI commands to deal with the Docker set of Docker commands, and also like I'm using the Azure Container Registry, not the Docker Hub. Okay, maybe I'm not finding it. Okay, just 1 minute. Huh? I think I found it.
Sure, sure.
I'll just paste it to you. The chat.
In the meanwhile, people, you can ask more questions.
Yep. Maybe Ashirwad, in case you can put it in the common chat.
Definitely. Just give me a minute. And this is the resource. You can find it in the chat window. And just for people who are interested, I can route them to our book. They can find it in Amazon. So this is the link of the book. That's also there on the comment section that Abhishek and I had co-authored. So you'll also get a great explanation over there, as Abhishek mentioned before. So yeah, have a look at there as well. And with that, I think we have no more questions for the day, and we can call it a day. Thank you so much, Abhishek, for your time, taking time out on a weekend. I do understand you have a busy schedule, but thank you so much for taking some time out for the community and sharing the knowledge, as you always have.
It's actually really wonderful to interact with the community and do it. It's an opportunity for me.
Thank you, Abhishek. It was a pleasure to host you. So, finally, let us go to the vote of thanks and thank all our speakers and sponsors. Who has helped. Who helped us sponsor this. Sponsor this event, and who has empowered us to actually share coupons and licenses, goodies with all of you. At first, I'd like to thank JetBrain. For sponsoring the JetBrain product licenses, and Microsoft for providing us with some goodies, and all the community partners, Serverless Bhubaneswar, Utkal Techies Forum, Azure Developer Community for making this event happen, and to all our speakers, Dhaval, Anuraj, Ambrish, Abhishek. Thank you so much for taking some time out on a busy weekend and spreading knowledge among the community members and sharing all your insights and expert opinions. We really value that, and thank you so much. And finally, I'd like to thank all our attendees for taking some time out to spend on reskilling themselves or learning themselves or exploring new topics. And we definitely want to have in-person events, but I know there are feedback that are coming in that we'd like to have more in-person events, but there are restrictions, there are some bottlenecks which we need to overcome. So we might go with the online way of things for some more time. But thank you so much for bearing with us, and for being part with us. With that, thank you, and have a good day. And for all the attendees, do check in your your emails. You might get some goodies. So with that, thank you. Have a good day. Take care. Bye.